Hello, class. This is Mr. Hart, and in this podcast, I want to cover the next part of the earthquakes chapter of our textbook. And in this part, we're going to look at some of the mechanics of how an earthquake actually works and how it sends waves through the earth and things like that. But first, let's look at two terms we commonly use to describe an earthquake. And one of those is the focus, and the other is the epicenter. Now, we might use those words interchangeably sometimes, but they actually mean something slightly different. Okay? So when an earthquake happens, it happens somewhere along a fault line, usually below the surface, and we call that location the focus. This is where the actual fracture is taking place, where the movement is occurring, which is causing the vibrations, which is causing the earthquake. Okay, that location is what we call the focus. Now, if you took a line directly from the focus to the Earth's surface, that would be the epicenter. Now, usually in the news and things like that, they use the word epicenter more often than the focus. Well, that's generally because the part we care about is on the surface, because there's generally, buildings and cities up here, okay, towns and things like that. And so the destruction that's occurring is near the epicenter, not near the focus. So that's why you might usually hear the word epicenter used more often than the focus, because that's the part that usually concerns us, because that's where our, civilization is, okay? But just realize that we can use the focus, we can use the epicenter, but they mean something slightly different, okay? Now, let's look at some of the waves that are sent when this fracturing occurs. So anytime there's a fracture or movement, we're going to send a couple of different waves, which we call seismic waves. Okay, so these are all the seismic waves of an earthquake. Okay, and again, apologies for this or the spelling with the touchpad; it's not the best. But these are seismic waves. Oops. Okay, so seismic meaning it's caused by an earthquake. Okay, and so there's two different categories of waves. There's what we call body waves, and there's what we call surface waves. Okay. Now, body waves are what waves that are going to actually go through the Earth's center, okay, go through the Earth's, mantle, and surface waves are just going to kind of propagate along the surface of the Earth, okay, not go through the core itself, okay, but just along the surface. So there's two different types of body waves. There's what we call P waves and S waves. So we'll look at each of these in a second, but you're going to want to know that there's a P wave and an S wave. Those are both body waves. And then you're going to want to know that surface waves travel along the Earth's surface. Okay. So, and if you look here, you can kind of see there's a difference between how these waves travel. P waves are going to be compressional waves. So you can imagine if I strike a hammer along the bottom of this, material, if I had like a slinky, for example, if you hit the bottom of the slinky, then it's going to send a wave that goes through and through and through, okay, in the same direction as the material. Whereas if I strike a hammer on this side of the material, okay, then that wave is not going to propagate along in the same direction. It's actually going to move perpendicular, right? It's going to stick out and move in that direction, okay? And then we have surface waves, which again move along the surface. Some go back and forth, okay, like this, okay, moving the surface back and forth, and then some move up and down like this, okay, so some move the surface back and forth, some move the surface up and down, okay. So again, what you need to know is there's body waves that go through the Earth, which are P waves and S waves, and then there's surface waves that travel along the surface, okay. Let's do some drawings of these to kind of get a better feel for what these are actually doing, okay. So if I have a P wave, for example, okay, then what's happening is there's molecules in the Earth's, material, okay, that are all connected to each other like this, okay. So here's a set of molecules that are bonded together. Here's a set of molecules or atoms that are bonded together, and they kind of make this, crystal structure. Obviously, there's some, non-symmetries in this material, but in a general sense, you're going to have this nice solid structure, okay? So what's going to happen is when that earthquake occurs, it's going to move something, okay, up here. It's going to shift it to the side, press it down, whatever is going to happen, but it's going to kind of push on it. You can again imagine a hammer or something striking these molecules. Well, when that happens, this molecule right here, okay, I'll do it in a different color. This molecule right here is going to want to move down, right? Well, that's not just going to move him down. That's going to move this guy down because he's bonded. That's going to move this guy down because he's bonded. And it's going to move this guy down because he's bonded as well. Well, now when those guys move down, they're going to want to move down as well, right? And these guys are going to want to move down as well. And this guy's going to want to move down as well. Okay, and so can you see how that's going to propagate naturally through the material? So even though it's consisting of the entire Earth, right? It's going through the entire Earth, that wave is going to keep traveling. Okay, so if here's the Earth, okay, here's the focus or the location of the earthquake, that wave is going to travel and keep just pushing down and pushing down and pushing down in all directions. Okay, that P wave is going to travel in all directions through the Earth. Okay, and it will travel slightly differently through different layers, and we'll get to that later. But we're going to have that same, they're going to have that same compressional wave going through the entire Earth. Okay. Then we have S waves. So S waves, same thing. We have our structure like this, okay? And everything's connected with the bonds. But now instead of coming from the top, it's coming from the side, right? So we have this nice lattice structure on the material, on the molecules. And when something strikes the side, oops, right there. When something strikes the side of the material, like this, again, there's going to be movement that occurs. So this guy's going to want to go this way, but also all the molecules that are bonded to him are going to want to move as well. So this guy's going to want to move, 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 and then the next layer is going to want to move, okay? And then the next layer is going to want to move. And so we get this kind of wave that is occurring, and if you look at it from the side, it'll make this kind of shape. It will start to do this kind of movement, and it will make, just what you think of when you make a wave, right? A translational wave is what it's called. Okay, so that movement is, again, perpendicular to how it travels. So if you look at, again, the Earth's layers, okay, here's the Earth, here's the focus. That wave is going to travel through as long as the materials are bonded. But if you remember when we learned from last chapter, the plate tectonics chapter, part of the Earth's core is liquid. Okay, so when those waves hit the liquid, they will not travel through them because liquid is not chemically bonded, or it's not bonded as well as other material, a solid material. So when this guy, if this guy wants to go down, for example, there's no reason for this guy over here to want to go down as well. So S waves do not travel in liquid because if one guy moves, well, the other guy has no reason to move as well. Okay, so S waves do not go through liquids. So not liquids, which is why they do not travel through the outer core, because it is liquid. Okay? And then the last wave we have is the S wave, the surface waves. And so, again, they travel similar to S waves. They have this translational propagation, okay, from the chemically bonded materials. But the key difference here is if this is the Earth, okay, then the S waves are traveling along the surface of the Earth, okay, not through its core. And so there's nothing going on inside. It's just all along the surface of the Earth. That's how these surface waves travel. Okay, they're similar to S waves in how they travel, but they go along the surface. Okay, so and I'm going to apologize for how sloppy the handwriting is. It's kind of hard to do this with the, mouse pad, but hopefully that makes sense. A couple of videos we watched in class that may help you understand this more. We did a lot of Khan Academy videos, and he does a great job of explaining this as well. So if you want to look these up, I'd recommend doing that. But he does one on the different seismic waves, like we talked about, surface and body waves and how they travel. It's at this link here. He does one on why S waves can't travel through solids, kind of showing similarly how the molecules have to be bonded. And then he does one on refraction of waves, which is really, really helpful for understanding why S waves don't go through liquid centers. So I highly recommend watching these different YouTube videos if you want more material or more help with these topics. Okay. The last thing we want to cover is tsunamis. But first, we want to know how we know about the Earth's layer is, again, refraction of the P waves and the inability of S waves to travel through liquids. So you want to understand that. Again, that goes through those Khan Academy videos. It kind of describes that. Okay, so we want to know how, that's how we know the Earth's layer is because of the refraction of the P waves and inability of S waves to travel through liquids. Okay, last thing is we want to understand is tsunamis. Okay, so a tsunami occurs when you have an earthquake that is near the ocean or in the ocean, okay, and it's going to cause large amounts of water to come up onto the surface. Okay, so tsunamis can be very deadly because what happens is you get an earthquake that happens, which causes a lot of structures to fall and things like that, and then the wave comes, which also will come in and wash away material, which is why they can be so damaging. Okay, so tsunamis are generated when an earthquake occurs in the ocean near land. So there's a picture of one that happened to Indonesia not too many years ago, and it occurred right off the coast. So if you look at these pictures, all the countries labeled in yellow actually could see some of the effects of the tsunami. Okay, so this tsunami was here. Obviously, Indonesia got the biggest impact, but some of these other countries also saw some effects from that earthquake. So again, the reason why these are so damaging is, first of all, you get an earthquake that starts vibrating the land, right, which is going to cause some destruction in the land, some structures to fail, and then you get all the water coming in from that tsunami, which is going to wash away material, wash away buildings, and so they can cause a lot of casualties. Okay, and so you do not want to be in a tsunami. It's not very fun. But one last thing I want you to see is that a tsunami is kind of like an ocean earthquake, you can think of it. And it's similar to when we were talking about hurricanes, how a hurricane is kind of like an ocean tornado. So a tornado is to a hurricane or a typhoon as a earthquake So a tornado is to typhoon as an earthquake is to a tsunami. Okay. So if a tornado happens on land, or if you have high winds on land, we get a tornado. If you have those high winds on the ocean, it's a typhoon or a hurricane, right? If you have an earthquake on land, okay, then it's just an earthquake. But if you have an earthquake in the ocean, it can be a tsunami. Okay, so very similar in how we describe them. And so I hopefully just wanted to have you see that connection. Okay, tornado is to hurricane or typhoon, as an earthquake is it's to a tsunami. Okay, so that's all we want to cover for today. Hopefully that makes sense. Again, I apologize for all the sloppy handwriting, but definitely go back and watch those Khan Academy videos as well. They will definitely help you in understanding some of these concepts. But let me know if you have any questions, and thank you for watching.